Good morning, children. Today we will move on to the next session of physics. So far we were studying about power transmission, generation, distribution, all that things, household electrical circuits, all these we have studied. Now what you have to study is what are the safety measures that we adopt in household electrification. So one main safety device or one safety measure we have already studied in an earlier lesson, that is a safety fuse. So what is a safety fuse? Safety fuse is a device that works on the principle of heating effect of electric current. That is, whenever there is an excess flow of electric current, that is due to short circuit or overloading, if there is an excess flow of electric current in a circuit, the fuse wire melts. Why does the fuse wire melt? Because the fuse wire is made of a metal having low melting point. And thus, if excess of current flows through the safety fuse, the fuse wire having low melting point gets heated and it melts. So, when the safety fuse or the fuse wire melts, the current cannot enter into your circuit and thus your circuit is protected. So, when the safety fuse wire breaks, what happens? The circuit is broken and your devices will be brought to safety. Now, after correcting the damages, you can use a fuse wire of suitable amperage and then rectify your circuit. Now, the next safety device is an MCB. What is an MCB? MCB is miniature circuit breaker. So, what happens is, if there is an excess flow of electric current in your circuit, MCB automatically breaks off. Then, after rectifying your problem, the MCB can be switched on. There is yet another one safety device that is known as ELCB, Earth Leakage Circuit Breaker. ELCB also has the same function of MCB, that is whenever there is a excess flow of current, what happens? ELCB helps to switch off the circuit automatically and thus your circuits are safer. Then nowadays, instead of this MCB and ELCB, RCCB, which is of greater quality, is now being used. So these are the safety devices that are assembled in a household electrification. Next, we will move on to the topic 3-pin plug and earthing. So you might have seen in your houses, many devices are connected to a 3-pin plug. What do you mean by a 3-pin plug? 3-pin plug has 3 pins. 2 identical pin and the other one will be a longer and broader pin. This pin is the earth pin. The earth pin is always connected to the metallic body of the appliance. So why is this earth pin connected to the metallic body of the appliance? If at all due to some insulation failure or anything, if the phase wire comes into contact with the metallic body of the appliance, what happens when a person touches the metallic body? Suppose take the case of an electric iron. Suppose due to some insulation failure or anything, the phase wire may be in contact with the metallic body of the electric iron and we, without knowing this thing, we touches the electric iron. What happens? We may get a shock. So, in order to avoid this instance of shock, earth pin is used. So, what happens is, earth pin is always connected to the metallic part of the appliance. Whenever there is an excess flow of electric current to the metallic part, this electric current is taken to the earth through the earth pin. Earth pin is connected to the earth with a path of low resistance. That is, a thicker wire is connected to the earth from the earth pin. So, as thicker wire is used, it offers a low resistance path to the flow of current. So, what happens? when excess amount or if electricity reaches the metallic part of the appliance, this electricity flows through the earth wire to the earth having a low resistance path. Since it is a low resistance path, what happens? The flow of electricity increases, or a large amount of electricity flows into this low resistance path. So, since a large amount of electricity flows through this low resistance path, the fuse wire gets heated and the fuse wire melts, thus breaking the circuit. So, a person who touches this electric appliance will not get a shock because the excess current is passed on to the earth pin and thereby to the earth, thereby cutting off the circuit. Now, if you examine a 3-pin plug, you can see the two identical pins are, one is a phase wire and the other is the neutral wire. And the third pin, which is longer and broader, is the earth pin. Why is it made broader? Because to ensure a low resistance path. We have studied as thickness increases, resistance decreases. So, as the earth pin have a broader pin, it offers a low resistance path. Then why is it made longer? It is made longer because when you insert a 3-pin plug into the socket, the longer earth pin will come into contact with the socket first. So if there is any chance of this electric shock, when the earth pin gets into the socket first, you will be rescued from the hazards of electric shock. And moreover, since this earth pin is longer, when it is taken out also, it is this earth pin that comes out of the socket last. So there also you can avoid the danger of electric shock. So the earth pin is always connected to the metallic part of the body, and whenever there is a hazard of electric shock, that is whenever electric current reaches the metallic part of the appliance, this electric current flows through the earth pin thereby to the earth, thereby creating a low resistance path. As a result, what happens? Since it is a low resistance path, the flow of electric current increases. As the flow of electric current increases, what happens? Heat also increases. Heat increases, the fuse wire melts and the circuit is rescued. This is the safety measure of a earth pin. Now we will move on to another interesting topic. That is, most of the devices that is used in your houses work in AC. That is alternating current. But there are certain devices that works on DC. The most familiar device to you that work on DC is your mobile phone. Mobile phone battery uses this DC, that is direct current. But we charge this mobile phone using the AC that is supplied to our home. Isn't it? We use the AC current that is coming into our home and thus we are charging the mobile phone. But mobile phone makes use of DC. How is this AC made into DC, or how these machines that work on DC work? Most of the machines that work on DC converts AC into DC within itself. So a mobile phone charger. When you charge a mobile phone, the charger that you insert into the socket, it converts the AC into a DC. The device which converts AC into DC is known as a rectifier. So mobile charging charger is a rectifier. It converts this AC into the DC. Now another thing is, we know the AC that we use or we get in your home is 230 volt. Now what happens is, in a mobile charger, this 230 volt AC is converted into 12 volt AC and then converted into 12 volt DC. So such equipments or such devices which converts AC into DC are known as rectifiers. Now there are certain instruments that work on AC and that work on DC. What are the instruments that work on AC? Most of the household instruments work on AC. And what are the instruments that work on DC? The instruments that work on DC is your mobile phone battery, then your torch that you use in your house, then clock, etc. are those instruments that work on DC. So up to this, we have studied about the safety measures and the electric current that is used in your household circuits. The next session, we will pass on to yet another interesting topic, that is electric shock. That is the last portion of this lesson. So we will meet again in the next session. Thank you.